The universe is not still. It is stretching outward in every direction, an expansion that has continued since the dawn of time. This growth is so vast and so relentless that it's nearly impossible to say where it begins or ends. Thanks to modern instruments, especially the James Webb Space Telescope, we are peering farther into the cosmos than ever before. Each image it returns offers a new layer of insight, revealing a scale that challenges imagination. What we see through its golden mirrors is only a fragment, a narrow window, of a universe that may extend without end. Astronomers estimate that within the observable universe alone, there are around 2 trillion galaxies. Yet even this astonishing number represents only what light has had time to deliver to our telescopes. Beyond that horizon may lie realms we will never witness. But we are not outside observers looking in. We are part of this vast system, woven from the same fabric as the stars and galaxies we study. Humanity itself is the universe becoming aware of its own existence. To grasp these mind-bending scales, let's bring it closer to home. Traveling at 70 miles per hour, you could circle Earth's equator in just over 2 weeks. At that same speed, you'd need 5 months to reach the Moon, 63 years to reach Mars at its closest, and more than 4,000 years to reach Neptune. Even Voyager 1, racing through space since 1977 at nearly 38,000 miles per hour, needed 35 years just to leave our solar system. Now compare that with light, the fastest traveler in existence. Light can circle Earth 7 times in a single second. Yet even this incredible speed struggles to bridge the vast gulfs between stars. Our solar system, enormous to us, is nothing more than a speck within the Milky Way, a galaxy containing some 300 billion stars, most with planets of their own. The nearest stellar neighbor, Alpha Centauri, is 4.3 light-years away. If Voyager were headed in that direction, it would take 70,000 years to arrive. When you look up at Betelgeuse, a red giant about 640 light-years away, you're seeing it as it was in the 14th century, long before the modern world existed. Meanwhile, our own radio signals have formed a bubble about 200 light-years across, a faint whisper barely touching a fraction of the stars in our galaxy. Imagine compressing our solar system to the size of a coin. On that scale, the Milky Way would be the size of planet Earth. Beyond it are countless other galaxies, each filled with billions or trillions of stars. Our neighbor, Andromeda, sits 2.5 million light-years away and contains roughly 1 trillion suns. In several billion years, the Milky Way and Andromeda will merge into a single giant galaxy, but the stars themselves will mostly glide past one another, untouched, because of the enormous distances separating them. Zoom out even further, and galaxies arrange themselves into clusters and superclusters. Our own home lies within the Laniakea supercluster, containing over 100,000 galaxies. These superclusters are not scattered randomly. They form part of a greater structure, the cosmic web. Filaments of gas, dust, dark matter, and galaxies stretch across billions of light-years, creating an interconnected framework that shapes the universe itself. Even the empty-looking regions, known as cosmic voids, are not truly empty. These vast expanses, hundreds of millions of light-years across, may one day become the birthplaces of new galaxies as matter drifts inward under gravity's pull. What appears barren today may be the foundation of creation tomorrow. The universe is not a static place. It breathes, it evolves, it transforms. At its heart lies a grand cycle, an endless rhythm of birth, growth, death, and renewal. Stars emerge from vast clouds of gas and dust, igniting nuclear fires that burn for millions or billions of years. They shine as beacons, lighting the darkness, nurturing planets, and shaping galaxies. But even the most brilliant stars cannot burn forever. When their fuel is spent, they collapse under their own gravity, some fading quietly, others ending in spectacular explosions. These violent deaths, called supernovae, scatter the very building blocks of life across space. Carbon, oxygen, iron, calcium, every essential element that makes planets solid, oceans flow, and living beings breathe, was born in those stellar furnaces. Every breath we take, every heartbeat, carries within it the ashes of ancient suns. In this sense, the universe is alive within us, and we are alive within it. But the story does not end there. Another set of actors dominates this cosmic drama: black holes. These mysterious objects are regions where gravity becomes so extreme that even light cannot escape. At the centers of galaxies, including our own Milky Way, lie supermassive black holes, millions or even billions of times more massive than our Sun. Far from being silent monsters, they shape the galaxies around them. Their pull regulates how stars are born, and their outbursts can unleash jets of energy stretching for thousands of light years. In their hunger, they also create something extraordinary: quasars. These are some of the brightest objects in existence, glowing with the energy of entire galaxies as matter spirals into the black hole's grip. The light from quasars has traveled billions of years across space to reach us, serving as messengers from a time when the universe itself was young. Through them, we glimpse an ancient past that no longer exists, preserved in light alone. And yet, with all this knowledge, one question always lingers: what lies beyond? How far does the universe go? Some galaxies are so remote that their light will never arrive at Earth, because space itself is expanding faster than light can travel. These regions, though real, are cut off from us forever. They remain hidden beyond what is called the cosmic horizon, a boundary not of matter, but of possibility. Scientists believe our observable universe, the part we can see, is only a fraction of the whole. Some models suggest it could be hundreds of times larger. Others hint at true infinity, an endless expanse with no edge, no center, no boundary at all. If so, then all we have ever known, every galaxy, every star, every planet, is merely a single droplet in a cosmic ocean without shores. In that vast ocean, our own fragile world orbits an ordinary star, in an ordinary galaxy, in one corner of one galactic cluster among trillions. It would be easy to feel small, even insignificant, when faced with such scales. But the truth is the opposite. Far from diminishing us, this knowledge reveals something profound. Out of unimaginable emptiness, life found a way. Against overwhelming odds, consciousness arose, capable of looking back at the universe and asking questions about its nature. We are not outsiders observing creation. We are creation. The iron in our blood, the calcium in our bones, the oxygen in our lungs, they were all forged in the hearts of stars. We are the cosmos turned inward, reflecting on itself. We are stardust that learned to wonder. And as we gaze further into the unknown, another timeless question rises above all others. Are we alone? In a universe so ancient, so immense, could there be other eyes staring back at the stars, asking the same questions, hoping they too are not alone? Perhaps civilizations exist beyond our horizon, forever unreachable. Perhaps we are rare, even unique. Or perhaps life is as natural to the cosmos as stars themselves. We may not discover the answer in our lifetimes. It may take centuries, millennia, or perhaps the truth will remain hidden forever. But the search itself, the curiosity, the journey, the act of reaching, is what defines us. It is what lifts us from mere survival into something greater.